This video is about proportions and dilution factors. So we're going to begin with proportions and just discussing what is a proportion. So if you have a pair of numbers and you want to know, hey, are these proportional? Okay. Basically, is 4/5 proportional to 10 over 12? A way you're basically asking, do these simplify to the same number? So one way of approaching this is asking yourself, can I make 10 over 12 look like 4 over 5 simply by dividing it by a common factor? So 2 can go into 10 and 2 can go into 12, and this will simplify down to 5 over 6. Well, 5 over 6 is not the same as 4 over 5, so no, these are not proportional. A different way to approach this is to say, if 4/5 could be simplified down to 10 over 12, then we could cross multiply and get an equality. So you could take this, you could cross multiply 4 times 12 and say, does 4 times 12 equal 5 times 10? And no, 48 does not equal to 50. So these are two different ways we could show that these numbers are not proportional. What about B? Is 4 over 5 proportional to 24 over 30? Well, I could do the same thing. I could cross multiply. I could say, does 4 times 30 equal to 5 times 24? And I would find that 4 times 30 is 120, and 5 times 24 is also 120, and I get an equality. So I'm saying yes. If I did it the alternate way, I could take 24 over 30, and I could say, can I simplify this guy down to look like 4 over 5? 6 can go into 24, and 6 can go into 30. So if I divide the numerator by 6, I get a 4, and 30 divided by 6, I get a 5, and I can make it look like 4/5 by simplifying it. Part C, we could try this. We could say, hey, does 4 times 25, does this equal to 5 times 16? And 4 times 25 is 100, and 5 times 16 is 80. These do not equal, and these numbers are not proportional. So A was no, B was yes, C was no. All right, so what does it mean if you have two figures? And we say, hey, these figures are proportional. What does that mean? Well, it means that they are the same shape. They're the same shape, but they're not the same size. If you want to think of these numbers, 4/5 and 16 and 24 over 30 as being the same shape but different sizes, you can think of it that way. These are the same shape but not the same size. So if two figures are proportional, then their corresponding sides, well, the length of the corresponding sides will also be proportional. 3 is to 12 as x is to 16, as 5 is to z. Or we could say 3 is to x, this side is to this side, as 12 is to 16. And if you hear me saying this, you can almost hear an equation coming out. I'm going to write the equation this time. I'm going to say 3 is to x as this side, 12 is to 16. And since I know these are proportional, I can solve for x. I could say 3 is to 5, 3 is to 5, as 12 is to z, as 12 is to z. Those are a couple of proportions I could set up. Here's some other proportions we could set up. You could say, I could say 3 is to 12, 3 is to 12, as 5 is to z, as 5 is to z. These are all true proportions. You could also say 3 is to 12, 3 is to 12, as x is to 16, as x is to 16. All of the things I have written are true statements and are okay proportions to write. Now, if you have a proportion, you know that statement's true, and you can solve for the variable like I did previously with cross multiplication. We can use that again. I could say 3 times 16, 48 is equal to 12 times x. And I can divide both sides by 12, and I'll get that x is equal to 4. What if I didn't use that? What if I didn't set it up that way, but I set it up this way? Okay, I could say 12 times x is equal to 3 times 16, and I would get x is 4. So either way is fine. Right here, 3 times z is equal to 5 times 12, which is 60. We'll get that z is 20. 3 times z is 12 times 5. We'll get that z is 20. Either way you do that. Okay, so what I'm demonstrating here is as long as you have a true proportion, it doesn't matter if you set them up slightly differently. To say that these triangles are proportional means that they're the same shape but different sizes. You might be interested in knowing how many times bigger. Well, 3 times 4 gives me 12. 5 times 4 gives me 20, which is what I said z was. And 4, which is what I said x was, times 4 gives me 16. The lengths of these sides are 4 times greater than the lengths of these sides. Okay, so now let's talk about something that you will see in biology, which is dilution factors. Okay, what is a dilution factor? What does it mean to have a dilution factor of 1 to 10? And what does it mean to have a dilution factor of 1 to 100? Well, a dilution factor is simply the volume of the stock material, the very concentrated material that you're given, the ratio of that to the total volume of the solution you are creating. So a stock material is the very concentrated stuff that you are mixing and you're diluting with something like, maybe something like water or a different solution that will make this not as concentrated. So that's basically what it means. So when I say you have a dilution factor of 1 to 10, you can write it like this, 1 to 10, right? Did you hear me say 3 is to 12 as 5 is to z, as 5 is to z? I could say 1 is to 10. You might say that, 1 to 10. So what this means is that there's going to be 1 part of the concentrated stock, and there's going to be 10 total parts of the volume. So if you drew a picture here, and you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my total solution right here, the end solution that I want to make. It's got 10 parts in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of the 10 parts, only one of them is going to have the stock in it. What does this mean? 1 out of 100. Well, that means you would have something that would have 100 parts, 100 parts, out of 100 parts, but only 1 part would have the stock in it, the concentrated solution. So let's see what this looks like in kind of word problems. Here are several examples of dilution factor problem. So the first one, if we want to make a 40 milliliters of a 1 to 10 dilution of a stock solution in diluent. I'm not sure how to say that word. I don't say it very often, ever, really. How do I do it? So how would you make this? So here's the key. You want 40 milliliters. That's how much you're going to end up with. So our dilution factor is 1 to 10. Okay. And 10 is going to be representative of the total volume. So 40 milliliters is going to be the total volume. And we do not know how many parts we need to use of the stock solution. You can just set up this proportion. You can say 1 to 10 is equal to, is proportional to, the amount of stock solution I need to use is to the total amount of volume that I'm going to have in my solution. So we can cross multiply and get 10 times x is equal to 40 milliliters. You can divide both sides by 10 and get 4 milliliters. How would you do it? We would mix 4 milliliters of the stock we need a total of 40 milliliters, and 4 of that's been taken up with the stock with 36 milliliters, or simply 40 minus 4 milliliters of the diluent. I don't know how to say that. I'm so sorry. Right there. All right, number 2. I have 100 liters of a concentrated solution, or the stock solution of acid, that I want to dilute down with a 1 to 3 dilution factor. I want 60 liters of the diluted acid. How do I do it? So 60 liters is what we want to end up with. Okay, that's kind of key to recognize. The dilution factor is 1 to 3, so 1 to 3 is my proportion. I want to end up with 60 liters, so this is going to be the total volume. How much of the stock, of the concentrated acid do I use? So we're going to cross multiply here and get 3x is 60. Divide by 3x is 20 liters. We need to use, so we're going to mix 20 liters of the concentrated acid. With, I've already used 20, I need 60 total, so 60 minus 20 with 40 liters of the diluent. I think of the diluent as just water, but it doesn't have to be water. Okay. 3. What is the dilution factor? We have to come up with a factor if you add 0.1 milliliters of stock to 9.9 milliliters of diluent. So if we have this much stock, 0.1 milliliters, so the diluent factor is the amount of stock you have over the total, right? So we're going to add 0.1 milliliters to 9.9 of a diluent. So the dilution factor is going to be the amount of stock, 0.1, over 0.1 plus 9.9, which is 10. So that's going to end up being, I have to do my decimals, this is going to be 1 over 100. So 1 to 100 is my dilution factor, or diluent factor. How did I get this from here to here? If you move the decimal to the right one, it's like multiplying by 10. I moved this decimal to the right one. So I said times 10 times 10 gave me, 0.1 times 10 gave me 1. 10 times 10 gave me 100. That's how I could get my factor there. Okay, number 4. How would you make 500 milliliters of a 1 to 250 dilution? All right, well, if we know how much we need, 500 milliliters is the total volume. We don't know how much of the stock to put in, but we know that the ratio is 1 to 250. We can simply cross multiply. So 500 times 1 is 500 milliliters. Is going to equal to 250 times x. We'll divide both sides by 250, and we will get 2 milliliters. How would we make this? We would mix 2 milliliters of the stock, the concentrated stuff, with 498 milliliters of the diluent in order to get 500 milliliters of this solution. All right, number 5. How would you prepare 20 milliliters of a 0.25 dilution? This is what we want to end up with. This is the final product. When provided with a 0.5 stock. So when I saw this problem, I thought about doing it like a mixture problem like I have seen in a long time ago in an early math class. So you might think of it like this. We're going to be mixing something concentrated with basically something like water in order to get our final product. So this little visual helped me a lot. How would you prepare? This is what we want to end up with. We want 20 milliliters with this percentage, 0.25%. Okay. This is my stock. This is my diluent, and this is my final mixture. Okay. All they tell us is you're provided with this percentage of stock solution. So this is the percentage of the stock solution. For all practical purposes, there's 0%. This is like water. There's 0% of the stock solution in what we're mixing it with. The question is, how much of this will I put in? And how much will I put in here is going to be 20 minus x. That's how much I have left to put in here. You can simply solve this by saying 0.5% times x, or 0.5 times x, plus 0 times this, well 0 times anything is 0, is equal to 0.25% times 20. And so we get 0.5x is equal to 0.25 times 20. And so let me do that. Which just gives me 5. And if I divide both sides by 0.5, I get 10. Okay, how could we do this? We could mix, we would need to mix 10 milliliters of this stock with 10 milliliters. Why 10? Because the amount that we mix in here has got to be 20 minus how much we put in there. 20 minus 10 of the diluent in order to get 20 milliliters of 0.25% dilution. All right. Number 6. How would you prepare 10 milliliters of a 0.10% dilution? This is what we want to end up with when you're provided with a 1% stock. Okay, I'm going to do a little picture. Here's the stock. Here's the water or diluent. And here's the final mixture. The final mixture needs to have 10 milligrams in it. And it's got to have this percentage, 0.10%. All right. What do we start with? We start with 1% stock. And I don't know how much stock to put in. This is basically, I'm thinking this as water. It may not be water, but it's something that's like water. And so how much do we put in here is 10 minus x, and this has got 0% of it in it. So I say 1 times x. 0 times anything is 0 is equal to 0.10 times 10. Well, 0.10 times 10 is 1. X is equal to 1 milliliter. All right, I will mix 1 milliliter of the 1% stock with 9 milliliters. 10 minus 1 is 9 milliliters of the diluent. All right, there's a part B to this. Then using, that was part A, here's part B. Then using this, then using a 0.10 stock, how would you prepare 10 milliliters of a 0.01 dilution? Okay, so this time, I'm still going to do this little setup. I just think it helps. This is the stock, 0.10% stock. I don't know how much to use. How would you prepare, this is what we want, 10 milliliters again of a 0.01. This is what we want to end up with. This has basically got 0. This is going to be 10 minus x is how much we use that. And this is my diluent, which I'm going to think of as water. 0.10 times x plus 0 times anything is equal to 0.01 times 10. All right, 0.1x is equal to 0.01 times 10. This is going to give me 0.1. I can divide both sides by 0.1, and x is going to be 1 again. So to get this one, even though the percentages were different, it worked out that you have to mix 1 milliliter of the 0.10% stock with 9 milliliters of water or the diluent to get 0.01%, 10 milliliters of the 0.01% solution. Okay, here is number 7. This is real simple. You need to make a 1 to 5 dilution of a solution. This is our ratio. By the way, the dilution factor is no units on it at all. It is unitless. It's just a ratio of numbers. You need to make 10 milliliters of the diluted solution. So this is what you need. This is the total volume. 10 milliliters go down. How much of the initial sample do you need? This is a simple problem. This is what we don't know, the initial sample. You can cross multiply here. 5x is 10 milliliters. Divide by 5, we'll get x is 2 milliliters. So we need to mix 2 milliliters of the initial sample with 10 minus 2, or 8 milliliters of the diluent, or water, whatever, however you think of that. Okay, so that's some proportion and some dilution factors.